MCV4U1 Chapter 2 Derivatives Session 9. In this session, we are going to work on Section 2.4 from the textbook, the Quotient Rule. Let's look at what we have done in this course. In Chapter 1, we got familiar with the concept of limit. Then we defined f prime of x, derivative of function f, as the limit of the difference quotient, f of x plus h minus f of x over h as h approaches 0. This is called limit definition of derivative or first principle. F prime of a is limit of f of a plus h minus f of a over h as h approaches 0, which is the same as limit of f of x minus f of a over x minus a as x approaches a. F prime of a is instantaneous rate of change of f of x at x equals a. It is slope of the tangent line to the graph of y equals f of x at point a and f of a on the graph of the function. We used first principle and we proved derivative of a constant function is 0, derivative of a linear function is the slope of the line, derivative of f of x equals mx plus b is f prime of x equals m, derivative of a x to the power of n is a n x to the power of n minus 1, derivative of addition of two functions is addition of derivatives of the function. Derivative of multiplication of two functions is derivative of first function times second function itself plus derivative of second function times first function itself. We also use the properties of limit and saw if c is a constant, derivative of cf is cf prime. In previous lesson, we briefly went over derivative of f over g, which is f times g inverse, and we proved that the derivative of a fraction is derivative of numerator times denominator itself minus derivative of denominator times numerator itself divided by denominator to the power of 2. Which is called quotient rule. In Leibniz notation, dx u over v is derivative of u with respect to x times v minus u times derivative of v with respect to x divided by v2 when u and v are functions of x. The proof is very straightforward by writing the function f over g as f times g to the power of -1, or assuming h of x is f over g, then h of x times g of x is f of x. We apply the product rule and we take the derivative of the both sides and isolate it for h prime of x. H prime of x would be f prime of x minus h of x g prime of x over g of x. H of x is f of x divided by g of x, common denominator, and having the formula. Example 1. Find the derivative of h of x equals 3x minus 4 divided by x2 plus 5. This derivative is derivative of numerator, which is 3, times denominator itself, x2 plus 5, derivative of denominator, which is 2x, times 3x minus 4, subtract these two, and divided by x2 plus 5 to the power of 2. If we simplify, we get the final result. Next question, example 2. Determine the equation of tangent line to the graph of y equals 2x over x2 plus 1 at x equals 0. Derivative of this function is 2 times x2 plus 1 minus 2x times 2x, derivative of denominator times numerator itself, divided by x2 plus 1 to the power of 2. If we plug 0 into the derivative, we find the slope of the tangent line, 2. Y minus y1 equals m times x minus x1. Therefore, the equation of the tangent at 0, 0 to the graph of the given function is y equals 2x. Next example. Determine the coordinates of each point on the graph of f of x equals 2x plus h over root x, where the tangent line is horizontal. The tangent line is horizontal when the slope is 0. We find the derivative of the function by using quotient rule. Derivative of 2x is 2, and derivative of root x is 1 over 2 root x. We proved this in one of our previous sessions. It can be written as x to the power of negative x to the power of 1 over 2 and take the derivative. By applying quotient rule, the derivative is 2 root x, derivative of numerator times denominator itself, minus derivative of the denominator 1 over 2 root x times numerator 2x plus 8. We take common denominator on the numerator of the function, 2x minus x minus 4 over root x, which is x minus 4, and divided by x root x. Derivative is 0 when x is 4. Therefore, at x equals, at point 4 and 8, the tangent line is horizontal. Let's recap the quotient rule. Derivative of h of x equals f of x divided by g of x is f prime of x g of x minus g prime of x f of x divided by g of x to the power of 2. The derivative of a quotient of two differentiable functions is not the quotient of the derivatives. To understand this section better, in next session we are going to work on question number 7, 8, 10, and 14. Thanks for watching.